video is on hydrates. A hydrate is a compound with a specific number of water molecules bound to it. An anhydrous salt is the compound that remains after water is driven off of a hydrate. So this is just your normal ionic compound salt. The formula for hydrates is we're going to use a dot, like a big dot there, to connect the formula of a compound to the number of waters per molecule. So if my compound is copper 2 sulfate, CuSO4, it is bound to 5 water molecules, so I write CuSO4 dot 5H20 to show that it's bound to 5 water molecules. Now on the next slide I'll show you what that looks like. To name a hydrate, I take my salt's name just like I normally would, so I have copper 2 sulfate here, and then to name the amount of waters attached to it, I take a prefix equal to the number of waters, so 5 here is penta, and then for my water I write hydrate. So here I have copper 2 sulfate is my salt, copper 2 sulfate, and then 5 waters gives me penta, hydrate, my ATE ending. There's a couple of different things we can do with hydrates. First is we can calculate the total mass of our hydrate. This is just like how we calculated the total mass of any one of our salts, like my molar mass, but this time I need to incorporate the waters that are attached and however many waters are attached. So my total mass includes the mass of my anhydrous salt plus my waters. So continuing with my example of copper 2 sulfate pentahydrate, I have my mass of my copper 2 sulfate, my CuSO4, 1 copper, 1 sulfur, 4 oxygens. Added together I get 159.62 grams per mole, plus my waters of hydrogen, 1.01 times the 2 that I have, plus my oxygen is 16.00 times the 1 that I have, gives me 18.02 grams per mole. But I have 5 water molecules with that 5 coefficient here. So 5 water molecules, and I multiply my number of waters times 5, gives me 90.01. So when I add these two together, I get my total amount of my mass for my copper 2 sulfate pentahydrate to be 249.72 grams per mole. These 5 water molecules kind of look like this, where my copper 2 sulfate's in the middle, and my 5 water molecules are attached to it, just coming off. Now another thing that we can do with our hydrates is we can calculate the percent of water in a hydrate. Just like I could calculate my percent composition of sulfur in copper 2 sulfate, I can calculate my percent of water inside of my hydrate. Now just like percents before, it's part over a whole times 100 gives me my percent, so my part's going to be my water, my whole is going to be my total mass, times 100 gives me my percent of water. So for my example of copper 2 sulfate pentahydrate, my mass of my water is 90.01 grams. My total mass is 249.72 grams. So I take my mass of my water, divided by my total mass times 100, gives me 90.01, divided by 249.72 times 100, gives me a percent of water in my hydrate of 36% water.